Fail balancing equation.
So, we now are starting back up.
And action. Late Lawrence just arrived. I told you not to fake it.
No, it's...
Alright, so we've got these different stops along the way. Now we can convert between any of these things pretty easily. Let's say we want to go from mass to individual molecules or individual atoms. We can do that by going through this little transition part right here, the moles. We can go from mass to moles. We can go from moles to mass. We can go from moles to individual molecules. We can go from individual molecules or atoms into moles, and then back over into mass. We can do any of those directions. So let's go in this direction over here. If we go from mass to moles, we need to divide by the molar mass of whatever thing we've got to wait for.
This makes it so much easier.
If we go from the moles to individual atoms or molecules, we're going to multiply by 6.022 times 10 to the 23rd.
Because I always get confused when to use the 6.022,
Exactly.
right?
And if you memorize this chart, you know where to go from where to where.
Yes.
GMA and M.
This is a quick fix if you don't understand the concepts. And if you don't understand the concepts and you just want to get a few things to memorize so you can do the questions, that's fine
So if I go from
for
mass
one day.
to individual-
But then you'll forget it and you'll have to relearn it again and again and again and again and again from all the other years of chemistry you take. If you take chemistry. Yeah.
So if you want to go from mass to individual atoms, it's going to be like both, right? Like
Yes,
both
first you'll do
dividing and
this,
multiplying.
then you'll do that. Okay? And I'll give you a problem right here. We can use this, but we'll also set it up with conversion that we've been used to. Now, let's say you want to go from individual molecules or atoms back into moles. Well, to do that, you divide your individual molecules or atoms by 6.022 times 10 to the 23rd. Okay. Now, if you want to go from moles of molecules or moles of atoms into mass, you multiply by the molar mass. Mn molar mass of whatever substance you've got. So, example.
I'm going to write that on my hand. Because you said we could write something on my hand.
Wait, did I memorize this? To write something on my hand.
No.
No, you know what I'm talking about.
You said we could write an E on our hand.
Yes.
Oh, that's it.
Use E, not, you know,
What do you mean?
not that E, yeah.
Now let's do
E
it
on the
back to-
calculator.
Don't use E.
Don't use E. Mr. Sand says don't use E. Use the E
Use
on
E.
your calculator. Okay. So example, convert 45 grams of, what do you want? Convert 45 grams of
Carbon.
Let's just do carbon.
Carbon.
We all know.
Because you always do
It's all
carbon.
point.
That was your carbon. But we got to convert it to something. We're going to convert it to, let's convert it to individual atoms. So how many atoms are in other words, how many atoms are in 45 grams of this?
Got it.
Now, I'm sure you do know, but what I'm going to do right now is I'm just going to set this up like this is showing, so we can see how this plays into a question like this. So this is really demand, it's not a question. Convert this to that. So, we start off with the grams, 45 grams. Okay? And we're going to multiply it by a conversion factor. The conversion factor is going to be 1 mole of C over 12.011 grams. Now that is the molar mass. So in a sense, you are dividing by the molar mass here. Okay? Which will then cross off the grams. So the grams are now cancelled. Okay? So we've done this step. Now we're in the units of moles. If you want to go from moles to individual atoms now, give me another conversion factor. 1 mole is 6.022 times 10 to the 23.
It's 1 mole of carbon, right?
Atoms.
I don't know.
Yes. Oh yes, this is 1 mole of carbon. Nice. So now you can cross off the mole of carbon, because that cancels each other. And we're left with the atoms. Now, I don't like to spend too much time calculating this, but let's just do it really quickly so you can check at home. 45 divided by 12.011 gives you a number. I'm going to multiply that answer by 6.022.
Wait, I always do 45 times 6.022 divided by 12.0.
What's your answer?
Yeah, that's the same thing. If you do it as like 45 times that fraction.
Right?
One
Yeah,
time I got
that's
it.
the same answer.
Wasn't right. So we only have 2 sig figs, so this is going to be 2.3.
Mr. Sam, what she's saying is she does 6.022 divided by 12.001 and then that times 45.
Wait, I got 2 points. Okay.
That's
Maybe press a different E. Wait, what kind of calculator is that?
Chinese.
Japanese?
Just
Really?
kidding.
All right.
No, it's not Japanese.
So that's how you do it.
It's like a Nintendo Wii.
Anthony, let's focus here. We've got individual molecules. Let's say we want to turn those into grams. Can you do that?
Yeah.
How would you do that? How would it be different?
If you just reverse it.
It would be reversed. Yes, we start off with atoms, or individual molecules. You divide by 6.022 times 10 to the 23rd. Then you would multiply by the molar mass to get the grams. So that would be the final mass. So that's moles.
When we were writing the answers, like, can we write E or should we write times 10
You
to
can
the
write
power?
E if you want. I understand.
Wait, that made it so much easier.
I keep forgetting how to do the E on the calculator, so tomorrow if I ask you, will you tell
Comma,
me?
second comma.
Yes. Second, comma.
Or second E.
Comma.
So E.
Wait,
Okay,
this
yeah,
is like...
well, the main button is.
Yeah, outside.
But you understand.
Is that your calculator?
And don't try to be all smart.
Right E.
See where it is?
Stick
Yeah, second.
E.
That's it.
And then you type in the number and
Not that kind of
That's it. So let's practice 6.022, then do second E, 23.
Moving series.
Yeah, I don't know what you're talking about.
Yeah, actually.
2, 3. That's it.
I don't know what
Okay?
you're
We've done it.
Gotcha.
Okay?
Next.
Next!
Okay.
We've done moles, now we do exo.
Oh, can I
and
ask
that's a
a
good
question?
This is bad.
Yeah. We did this in the other class. Remember, Michael?
Another E.
I'll leave this up on the board.
Okay.
Okay,
True or
the one
false?
that said heating up an endothermic reaction will create more reactants.
Yeah, we did this in our class. Products. Let's do it the other way around. Let's do heating up.
Well, I knew they both had to be the same answer because you wrote the same thing twice.
Heating up.
Except
Let's do
exo.
exothermic.
Exactly, so then they both had to be the same answer.
I probably got the wrong one.
Reactions.
Can you
Gives.
see me in the camera right now?
Wait, can you
Not at
do,
all?
like,
No.
endo-
Alright, here, they can see.
We've already gone over there with that. Look, you can see it's. I'll tell you how to solve. Gives.
I drew the graph for the, and then followed it that way, but then it got confusing.
More reactive.
Yeah.
All right. You don't need to draw the graph. All you need to draw is an abstract equation showing that this is an exothermic reaction. So the easiest way to show that, if it's true or false, is to draw out this reaction. So A going to B. That's the simplest kind of reaction you can get. If this reaction is exothermic, and this we'll call the reactants, and this we'll call the products.
And where do you find these questions?
It was on the quiz.
Is this as far as you'll go in terms of how difficult a
Do you mind if I take that
exo
quiz?
and
Did they
nothing
take it?
question will be on the
Take
test?
the quiz? I was in your private.
Exothermic reactions, I'll answer that in just one second, okay? Exothermic reactions will give you heat as a product, right?
Wait,
Yeah.
what?
Right?
Yeah.
It's an exothermic reaction. An endothermic reaction would give you heat as a
Oh,
reactant.
Is it true or false?
That's it.
Okay, because I think of
Now-
heat, like you
now-
feel heat, it's a product.
Now, this is a product over here. It's become part of the products. Since we've written it like this, is now a product. So, just like any product, this could be C over here if we wanted to, but it's heat. We just have it written out, heat. Treat it like it's a product though. So if you add more heat, so you're adding more of this product, that's your stress.
Get less is B.
That's your stress. So what's the consequence of that? It's going to use up, it's going to chew up more of the B, right? It's going to react with the B more often, so that'll give you less overall B, and therefore, since it's reacting more often with that B, and it eventually chews up that, it's going to give you more of those reactants. So this over
So
here
that's true.
is true. So it's a true or false question that's really difficult, actually.
But like, what I understand, if one goes up and one goes down, doesn't it equal each other out?
No, it's what is the reaction to that stress? That's what I'm asking, right? So overall, the other products, besides the one that you messed around with, right, that's what the question is. Besides the one that you've messed with, what's going on with the products and what's going on with the
More of them
reactants?
are reacting.
More of them are reacting, so there's less of them overall,
Yeah.
and there's going to be more of the reactants.
Oh, sorry, I saw reactants. Alright.
Lawrence.
Is this as hard as the question's going to be in terms of endo-exo questions on the test? Because like what?
Well, you say like explain endo and exothermic reaction.
This is how I would ask it.
So it wouldn't be like this graph or like this equation or something like that.
You have to be familiar with what this means. If you can write out this with any endo-exothermic reaction, I would suggest you write out an equation like this. This is an exo, and endo would be heat written on this side, on the reactant side. Okay?
Are you gonna like give a question like you show us the graph and go like which one's endo, which one's exo?
I could, but that would be really easy though.
Yeah.
So here's the starting energy. If it goes down below the starting energy, that means it's giving off
Are you
energy.
doing the career thing tomorrow? I'm doing it.
So that would be
Come
exo.
do it. We have a study hall for 10
And over
minutes.
here, it would be by definition.
While we went.
Since you're putting heat in,
Yeah.
it's going to be endo. That's right.
Wait, I thought you said that's too easy to give on.
That is pretty easy.
So
I'm just saying.
can we count it out?
I'm just saying it's pretty easy.
Who's just saying?
But I think
So
you
so
should-
easy. I mean,
I think you should give that as
So
an
easy
extra
can
credit
make
question.
him do it.
Yeah, remember so easy K-Man can do it?
So easy, Harris.
yes, I remember that.
That's what my joke was for Mr. Bragg. Remember, you were like,
It's a pretty good joke.
I think we're getting a little off topic with the keyword.
So, any other questions about endo-exo?
Nope.
You guys pretty happy with that?
Yeah.
Okay, good.
I haven't even seen Leonard the whole time. have I?
you made
Snuck
moles
in.
so much easier in 1 second. It just makes so much more sense now with that thing up there, right?
What?
Now you
That's
got-
because he wanted
It's
us
like,
to learn it.
it makes so much sense.
Yes! Lawrence has got it. I want you to learn what was going on.
I'm gonna
Yeah,
learn
but
it.
I don't have to learn it.
First
It's
thing
an
I'm gonna do,
equation.
I don't have to learn it
The
now.
first thing we're gonna do on the test is write this on
Right,
top.
yeah.
Just write GMA. That's gonna be the first thing we're gonna do.
So any compliments.
Come on, Tony. Because I'm gonna forget it.
Come on, Tony. Be honest with me.
Yeah.
You're gonna get points on it.
No, I didn't do anything wrong.
So we've done this, done this, done this. Now we've got KEQ and we've got Lechat. We've got Lechat.
What?
The what?
Not Lechat, yeah. No. KEQ. KEQ. Let's just do, I like abstract equations, so let's do that. So
Abstract.
let's do 2a plus 4b will be in equilibrium with, let's do 3c plus
This
d.
is the shit.
Mr. Sand.
Okay?
Miss Sayers tells me that everything I make in art class is abstract. Is that a bad thing?
That's a horrible
Yeah.
thing.
Well,
Especially when you're going for
Well,
still.
Mr. Sayers is an abstract artist, and he's not
Especially when
going
you're
to
going for
person
still
ass.
so let's say that we have a K, we want to write a KEQ for this, and we're given all of these concentrations. So concentration, of course, means molarity. So we're given the molarities for all of them.
I don't think it's
Okay? For A, B, C, and D. All the molarities are given. And you have to figure out the KEQ. Or, I could give you a question where I give you the KEQ, which is the equilibrium constant, and I leave one of these blank. You could solve for one of those things that are blank. I hope.
Yeah.
Okay. So for this problem, this is what Rico was talking about before. We've got, I use these brackets to show that it's concentration, so that means the molarity of C, and that's going to be raised to the third power, times, I'm doing the products first, the molarity of D, and there's just raised to the first power, just 1 in front of it. Now we've got the reactants on the bottom. The reactants on the bottom. You can do them in either order, it doesn't matter. So I'm going to do A first. That's going to be raised to the 2. It's right there. We got that taken care of.